All right, we are very much towards the end of Unit 2 here. We're starting to clean a few things up. So today, we're going to take a look at solving equations that involve radicals. Now, a couple of things here at the start. First, reminder, the square root of x, x to the 1/2, one and the same. So no, it is not time to go anywhere yet. This is what I do during preps sometimes. So make sure that doesn't, kind of get you into trouble here going, I don't know what to do with 1/2. It's the same thing as the square root. So when we go to solve these equations, there are two ways we can do this. I'm going to show you both. And as long as I'm not specifically asking you, solve algebraically, solve using the calculator, you can do either, okay? Now, the other part before we jump in on the first one, I guess I'll call it a warning. Remember to check for extraneous solutions. Remember, that's when we've done all the math work right, yet our answer isn't quite clicking. So what's an example of that going to be as we're looking at these? Well, does it cause the radical to become negative? Because remember, we're not, fit in the screen there. We're not looking for I values. We're looking for real number solutions. So if I would get something like that, I won't have it. And there'll be another piece to this coming up in just a little bit. So as we look at these first couple, I'm going to do them algebraically. So if I'm going to do it algebraically, I'm like, okay, well, first I see x's on both sides, and I also see a radical. So first job, get the radical out of the way. So what's the opposite of taking the square root of something? Well, I'm going to square it. So squared and square root, inverses, I get x squared here on the other side. Once that radical's gone, I notice, okay, I have a quadratic, which means a couple of things. One, normally two answers, not always. But since I'm going to get this here, whether I'm using the quadratic formula or whether I'm going to factor, I want all my terms on the x squared side, especially since it's positive. So I'm going to add over the 2x. I'm going to add over the 1. And now I have a choice. Do I want to factor it? Do I want to use the quadratic formula? I like factoring better, so that's the route I'm going to go. But if you like the quadratic formula better, you go with that. But again, we're solving. Don't just factor and be done. Since it's the same quantity, the same set of parentheses, I've only got to solve it once. But before you go, okay, I'm all right, it's a double root, it's -1, I'm going on to the next one. Stop. Think. What if I plug it back in? So -1 minus 2 times -1. Okay, let's see here. So -1 minus 2 times -1 equals -1. Now, personally, I already see a problem, but you may not. So let's keep rolling here for a minute. So negative times negative is positive. -1 plus 2 is the square root of 1. Does the square root of 1 equal -1? Nope. You're like, well, wait a minute. If that doesn't work, then that answer doesn't work. I don't even have another answer. So now what? No solution. Okay? I can have no answers. I can have one answer. I can have two answers. But, again, it can be any of the above. So I kind of keep playing with these a bit. And I'm like, okay, let's take a look at another one. Now, again, that's just like square root. Rewrite it as square root if you want to. Because here, again, I'm like, okay, squared, because 2 times 1/2 is 1. Still cancels out. On the right, it just gets me what's left in the parentheses in this case, or under the radical like it did on number 1. Same thing as before. Everything to the x squared side. So opposites to get it there. Don't get sloppy. Factor it out. Quadratic formula it out. Whatever you got to do. And then just remind yourself when you're solving, your answers are not -2 and -5. Because you're setting those equal to 0. It's going to change the signs on both of those. Again, Let's see what's going on here. Now, unlike the last one where I know I'm not going to take the square root and get a negative number, that's kind of was obvious to me at the start that that wasn't going to work. I don't have that situation this time. So I'm actually going to plug these in and see how this goes. Negative 10 plus 7 times 2 is 14. So that's 4. The square root of 4 is 2. Okay, that one's good. 5. 7 times 5 is 35. Minus 10 is 25. The square root of 25 is 5. Both are good this time. And I kind of keep rolling with that. And I'm like, okay, this isn't too terribly awful so far. All right, let's check out one more algebraically, and then we're going to give you another option here. So you're like, okay, this is getting a bit tedious. Square both sides. One thing I will mention, if sometime you get a side that's not the radical and there's other stuff going on, you may want to try and isolate it. It depends. We're going to see one like that here towards the end. But same situation. Move the negative m over with an opposite. Move the positive 30 over with an opposite. And at this point, we should be getting really quick at these, especially when they're just x squared. I'm not having to do a bunch of guess and check, at least not much. 6 and 5, get my positive 1 in the middle. And basically, I'm taking opposites of both of those. Now, again, once we get to be a good sleuth here, a good detective, I look at the right side. I'm like, okay, the right side is just my m values. Can I take a square root and get a negative? No, we just figured that out up here. Okay, negative 6 I know is not going to work. I don't even have to plug it in. Taking a square root, I'm not getting a negative number. But let's try 5 out. 30 minus 5 is 25. Square root of 25 is 5. That one works. So algebraically, we'll work on all of these. Never a problem if I go that route. Here's my other option, though. I can do these using the graphing calculator. So we're going to start here with number 4. I'm going to do this on the graphing calculator. You can even go back and see if the other ones would work the same way. We'll take a peek here momentarily. And so what I'm going to do is I'm going to take each side of my expression and give it its own line in my y equals. Now, this will be another one of those things. Sometimes it'll be advantageous to go to the calculator. Sometimes it may cause us more of a problem. So I'm going to kind of let you see how this works. So, if I graph this, I'm going to watch to see where the two graphs intersect. So it looks like they intersect right around 4. Okay, so there's a couple of ways I could be able to find that. One is to go back to my old favorite, second trace. We're not looking for a 0. We're not looking for a min or a max. We're looking for where they intersect. So what it's going to do, and I need my cursor to show up somewhere here. There it is. Okay. First curve. Just watch to see which curve it's on. In my case, it's in the red curve. So I'm going to hit enter. Second curve. Again, I may have to hit up or down to get it moving a little bit. But I need to move it around until I get it onto that second curve. I hit enter. I don't need to do a guess. Oh, bad guess. Okay, you're like, see, calculator, not doing what I want it to. Let me get back to the graph for a minute. Like, but it looks like it is. Okay, let's look at the chart. This is where we have to be problem solvers and kind of look at this. So if I go to the chart, here's what I'm looking for. If I see the same y value for both of them, the x value is the solution. If I plug in 4, 4 minus 3 is 1, the square root of 1 is 1. If I plug in 4, 9 minus 8 is 1, the square root of 1 is 1. I'll spit it out. And I can get my solution. Absolutely legitimate. Okay? trying to figure out there a minute ago what happened with my intersection. But like I said, that's a problem we can run into sometimes with technology. But it can work. Oh, let's see. Let's find another one here. All right. 8 I want to use as a double example. I want to do this algebraically and using the calculator. So let's go back to the calculator again here for a minute. See if we can fix up some of this stuff. 40 minus 4x. You probably got somebody in the class by now going, I know what to do. I know what to do. I'd be like, if only I was doing this during class instead. So I look at my graph. Now it looks like, I can't see it real, but it looks like over here, it's going to intersect. Okay, Harty's going back to the well again. I'm going to try this again. If I get burned by this again, I don't even know where I'm going to go. So, all right. I calculated the 0. You're like, Harty, you're looking for the intersection. I knew that. I knew that. So first curve's the blue. I'm going to hit enter. Second curve's the red. I'm going to hit enter. I don't know why this is having issues. Great thing about technology, except when it don't work. Okay. So let's go back charting and see if we can find... Now again, if you're going to go charting, y's got to be the same. Oh, y's got to be the same. Okay. So I got my answer there. Now, let's... Some of you are like, oh, I like that a heck of a lot better. You will unless you get to like a fractional answer sometime. Then it might not be quite so fun. So, here's the catch on number 8 when I go this way. Again, algebra always works. On the left side, pretty normal. Okay. On the right, I don't know how many times we've said this, but I'm going to say it again here. Do not just distribute the squared and call this k squared plus 100. You've got to FOIL this out. If you've got to go over to the side and FOIL or box this out, do that. Because you are going to get k squared. But you're also going to get a middle term. So it's not just k squared plus 100. It's k squared minus 20k plus 100. And now we can do it like we were doing the ones up above. Everything to the k squared side, that's where the party's going on. Add the 4k minus the 40. And then your choice between factoring in the quadratic formula. So let's see, negative 10 and negative 6 multiplied to 60, add to negative 16. K equals 6 and 10. You're like, wait a minute, I'm getting 2 answers this time. Oh yeah. If I plug in 6, 6 minus 10 is negative 4. Can the square root equal a negative? No. 4 times 10 is 40. 40 minus 40 is 0. Square root of 0 is 0. 10 minus 10 is 0. Algebraic, calculator, whatever it takes to get there. Okay? So last one we're going to take a peek at. I keep feeling as though I need to try the calculator one more time, but I don't know. But let's say we stay away from the calculator. I'll go for the big finale with the calculator. We always need to isolate our radical before we start this, no matter what. So here, I'm going to get that out of there before I even attempt this. Okay, now it's looking a little bit more like the last one we did. We'll get this squared. To help on time a little bit here, I will do the foiling here for you. And now we're basically in the same situation we were on 8 once we made that small adjustment. We're going to get everything to the m squared side, so we're going to minus another 1m. We're going add the 4. Factor this out. Let's see here. 8 and 5. So m equals 8, m equals 5. But do they? Let's find out. Let's see here. 8 minus 4 is 4. Square root of 4 is 2. 2 minus 8 equals negative 6. Okay, that one works. 5 minus 4 is 1. The square root of 1 is 1. 1 minus 5 is not thus negative 6. I get one answer. All right, I'm going to be brave. I've already gone swing and a miss twice. Might have to be an addendum to this video later once I figure out what's going on if this doesn't work. So again, I'm going to go to my isolated version here. So x minus 4, x minus 6. No radical on this one. And again, we're not doing the squared and stuff. It's before we start doing any of the manipulating besides getting the m to that side. Okay. Give this a shot again. There it is. I can see it right there. It looks like it's about 8. Okay, let's try it again. Intersect. It's like, do you want me to get right up on it? First curve. Okay, I'm on the blue one. This is normally all I need to do. Second curve. All right, let's try to get real close. Let's see if that helps me. Guess. Hey! Third time's a charm. Thing I've got to remember is when I do that, maybe I just needed to get closer the first 2 times. The x value is my answer. Okay, I don't want both. That's the only one. Well, that's a nice way to finish. So on the back, you will find a few practice problems. Again, pick your way of going after it. Don't care which. But just have a little way of working with both if you want to. And if you're only going to pick one, go algebraic, because you don't need a calculator for that. So hopefully that gets you set. Otherwise, we can ask some questions later.